We will now introduce the control panels for the electrical system. 5 electrical panels are on the overhead panel in the cockpit, and 2 panels elsewhere in the airplane have several electrical controls and indicators. We will start near the bottom of the overhead panel and work up, just as we did with the schematic. Then we will discuss the APU panel and the 2 panels which are not in the cockpit. Right now, the schematic represents the electrical system when only the hot battery bus is powered. Powering the battery bus supplies power to the generator off bus, bus off, and transfer bus off lights. Now touch the battery bus on the schematic to power it. Each generator off bus light comes on when its associated generator breaker is open. Each bus off light comes on when its associated generator bus is not. Each transfer bus off light comes on when its associated transfer bus is not. Any amber light on this panel triggers the electrical annunciator light and the master caution lights on the glare shield. The APU generator off bus light is armed whenever the APU control switch, which is on another panel, is positioned to on or start. Once the light is armed, it comes on after the APU has reached normal operating speed, with both APU generator breakers open. If the light is not on, at least one APU generator breaker is closed, or the APU control switch is positioned to off. The ground power available light comes on whenever ground power is both connected to the airplane and operating, and it stays on when ground power is supplying power to the airplane generator buses. It does not indicate whether the voltage, frequency, or phase of the ground power unit is of the correct value, nor does it indicate whether the ground power relays are closed or open. Notice that the APU generator currently powers both generator buses and that ground power is available. The ground power switch is a 3-position switch, spring-loaded from on and off to the center neutral position. The generator off bus lights are on because both generator breakers are open. Now touch the ground power switch to move it momentarily to on. Momentarily moving the ground power switch to on initiates 3 automatic processes. First, the acceptability of the selected power source is checked by the bus protection. Then, if the selected power source is acceptable, the previously connected power source is removed from both generator buses. Finally, ground power relays 1 and 2 are closed, connecting ground power to both generator buses. The APU generator off bus light indicates that the APU generator is operating, but both APU generator breakers are open. Now touch the ground power switch again to move it momentarily to off. Momentarily moving the ground power switch to off disconnects ground power from both generator buses by opening both ground power relays. Each AC amperes meter indicates the load in amperes of the respective engine-driven generator. The maximum load you should allow, whether in flight or on the ground, is 125 amps. The bus transfer switch is a 2-position switch, guarded to the auto position. The auto position of the bus transfer switch allows for the automatic transfer of either transfer bus to the opposite generator bus if the associated generator bus loses power. Now touch generator breaker 1 to open it. When the bus transfer switch is in the auto position, several things occur if generator bus 1 loses power. The left bus off light comes on to indicate that generator bus 1 is not powered. Main bus 1 and the ground service bus are also unpowered. The loss of either generator bus causes a protective circuit known as auto load shedding to depower the galley. Bus transfer relay 1 moves to the alternate position, allowing generator bus 2 to power transfer bus 1. The battery charger transfer relay changes position, allowing the battery charger to transfer to main bus. Notice that the generator 2 AC amperes meter shows an increased load, but because of auto load shedding, it does not indicate an. And finally, the standby hydraulic pump, normally powered from generator bus 1, also transfers to generator bus 2. The schematic has been restored to represent the electrical system in normal flight configuration. Now touch generator breaker 2 to see the effects of the loss of generator 2. If generator bus 2 is not powered when the bus transfer switch is in the auto position, several things occur. The right bus off light comes on to indicate that generator bus 2 is not powered. Main bus 2 is also on. The automatic load shedding of galley power occurs. Bus transfer relay 2 moves to the alternate position, allowing generator bus 1 to power transfer bus 2. Since TR3 is unpowered, the battery bus transfers to its alternate source, the hot battery bus. The schematic has again been restored to represent the electrical system in normal flight configuration. Now touch the bus transfer switch to position it to off. The off position of the bus transfer switch opens the disconnect relay, isolating System 1 and System 2, and prevents the transfer of a transfer bus if its associated generator bus is lost. Now touch generator breaker 1 to open it. If generator bus 1 is not powered when the transfer switch is positioned to off, several things occur. The left transfer bus off light comes on to indicate that transfer bus 1 is not, and the battery charger is prevented from switching to its alternate source, leaving it unpowered. Notice that the standby hydraulic pump still transfers to generator bus 2, regardless of how the bus transfer switch is positioned. Standby buses are now powered by their alternate source of power, the battery bus. Notice in this scenario that the APU generator is powering both generator buses. The generator 1 and generator 2 switches are 3-position switches, spring-loaded to the center neutral position. Now touch the generator 1 switch to move it momentarily to on. Momentarily moving the generator 1 switch to on initiates several automatic processes. First, the acceptability of generator 1 power is checked by its generator control unit. If generator 1 power is acceptable, any previously connected power source is disconnected from generator bus 1. If the generator 1 field relay is open, it is closed, and finally, generator breaker 1 is closed. Now touch the generator 1 switch to move it momentarily to off. Momentarily moving the generator 1 switch to off opens the respective generator field relay, which in turn opens the respective generator breaker. Notice that in this scenario, the loss of power to generator bus 1 has resulted in the transfer of transfer bus 1 to the opposite generator bus. The generator 2 switch operates in exactly the same manner. The left and right APU generator switches control APU generator breakers 1 and 2, respectively. The APU generator switches operate in exactly the same manner as the engine generator switches. Momentarily moving an APU generator switch to on does 4 things. The generator control unit checks the acceptability of APU power. disconnects any previously connected power source from the associated generator, closes the APU field relay if it was open, and closes the associated APU generator breaker. Momentarily moving an APU generator switch to off does two things. It opens the associated APU generator and opens the APU field relay if the APU generator is not being used to power the other generator bus.